Salutations, mini mathematicians. So happy you could be with us today. We're doing 4.2b solving systems with mixed strategies. So given a system, you're going to decide which method, graphing, substitution, or elimination, is most efficient. So let's get started. 4.2b lesson. Taking a look, what I would like you to do first is I'd like you to solve this system, graphing, substitution, and elimination, and then decide which method you prefer. So go ahead and pause the video and finish solving the system with all three methods and think about which method you prefer. Let's take a look. So when you went to solve this, the first thing I looked at is I labeled these 1 and 2. When I looked at the first one, I saw that the y-intercept, since this is written in standard form, it's the ratio of c over b, and negative 12 over negative 6 is 2. And then I saw the slope. And I did the same thing for equation 2. I saw what the x-intercept or y-intercept is here, and then the slope. And when I graphed these, I could not tell what is the point of intersection because it's not really on an intersection of the grid line, so they're not integer intersection points. When I did substitution, I noticed in equation 2, x was already had a coefficient of 1. So since x had a coefficient of 1, it was really efficient to isolate x and then substitute that into equation 1 for x and solve for y, and then substitute back in for x. Remember, it's a dance. Isolate, substitute, isolate, substitute. And I was able to get my answer as an ordered pair, and then I was able to confirm with the graph. It does look like it's -1 and then up 1/2. With elimination, looking at this method, this system with elimination, I saw that we already had our variable terms and equal signs lined up, which was nice. And because the y terms were opposite signs and multiples of each other, I decided to multiply equation 2 by 3 to eliminate the y's. So which method was most efficient here? Which method was most efficient here? So most efficient means it takes, it's the most accurate, it takes less time. I would say that the most accurate and most efficient would be substitution or elimination. Graphing is not accurate here. So let's take a look at the next set of problems. So the next set of problems, we have 6 problems, and it's asking us to examine the given system, state whether elimination, substitution, or graphing would be the best method to use to solve, and explain your reasoning using the structure of the equations. Remember, structure is how the equations are made up of. Is there a variable already isolated? So substitution is going to be most efficient. Are the like terms already lined up with opposite signs or additive inverses already? So when you add the system, one of the variables cancels out. Are the equations already written in slope-intercept form? So graphing is going to be most efficient. So we're going to explain using the structure of the equations and then solve the system with the method you chose and show all your work. So taking a look, let's go through and just pre-think about what method is most efficient. And a lot of these, you can solve them with any of the methods, but one of them is going to be a little more efficient, and we want to work smart, not hard. So let's take a look at number 3. Taking a look at number 3, I see that the x is already isolated. I am going to label these equations 1 and 2 so we can explain. So because this x is already isolated, the best method would be substitution. I know a lot of you are in love with the elimination method. However, if you did elimination, you'd have to rewrite this equation to match, and then you'd still need to multiply to make additive inverses to add the system and cancel out a variable. So substitution is going to be the most efficient. It's going to get the job done quicker with less steps, and less steps means less chances for mistakes. So substitution, equation 2 has x isolated. and then we would solve. Okay, let's take a look at number 4. Okay, well, looking at number 4, we don't have any terms isolated already. We do have the terms already lined up with our y's being opposites. So I would think that the most efficient method here, that's right, is elimination. Elimination. So I'm going to label these 1 and 2 so we can talk about them. Elimination, like terms, are lined up. Eliminate y by multiplying equation. I'm going to use EQN for equation. Equation 1 by 4 and add the system. So I'm already noticing that the y's have opposite signs. Cool. Okay, let's look at 5. Oh my gosh, what form are they already written in? Oh yeah, slope-intercept form. So the best to do here would be graphing. And in fact, if we choose graphing, we don't even actually have to graph because we can just talk about what the graph will look like. Graphing, and based on the structure, both equations are written in slope-intercept form. Remember, which is y equals mx plus b. Clearly showing that these lines have the same slope and what else do you notice about them? That's right, different y-intercepts. Hence, what do we know? The lines are parallel. With no point of intersection. Point or points, we should say. Therefore, make us sound like we know what we're talking about. Fake it till you make it. This system has no solution. So we solved this one in talking about the structure. Nice. Let's look at number 6. Okay, well, number 6, we can look at the structure. Y is already isolated in equation 2. So let's think about what method would be most efficient. Okay, so you are going to finish solving 3, 4. Tell me what method is most efficient for 6 and solve. Tell me what method is most efficient for 7 and solve using that method. And the same for 8. Tell me what method is most efficient and then finish solving. Pause the video and finish this page and we'll talk about it in just a second. Okay, let's see how we did. Taking a look at problem number 3, when we're solving with substitution, I found my y value to be 2 and my x value to be 9. So my answer written as an ordered pair with a little bit of flair is 9, 2. For number 4, we decided elimination was most efficient. So when I did that and added my system cancel out y, I found x to be -1. And when I substituted back into either equation, I chose equation 1. I got y to be 4, so my answer as an ordered pair is -1, 4, of course with parentheses, and I gave it a little flair. Taking a look at 6, substitution was the most efficient method. Hopefully you got that, because in equation 2, the y is already isolated. From here, I substituted in that y value, which is negative 2x plus 5, in for y, and solved for x, and I got x equals 1. Substituted that back into the equation where y is isolated, and I got y to be 3, and finally wrote my answer as an ordered pair, 1, 3. Number 7, substitution is the most efficient because x is already isolated. Maybe you thought about multiplying both sides by 4 to clear that fraction. You could have done that, but remember, we want to look at the original structure before we do things to the equation on this page. So taking a look, when I do substitute that value for x into x in equation 1, the fraction disappears. Woo! Math magic. From here, I get a true statement. The variables cancel out, and I'm left with a true statement, 12 equals 12. So that tells me, since this is true, we end up with infinitely many solutions. Remember, when solving an equation, if the variables cancel out, you get a true statement, it's infinitely many solutions. If the variables cancel out and you get a false statement, it's no solution. And number 8, elimination is the most efficient here. You maybe said substitution because you can just subtract 0.25y from both sides and get x isolated. I totally understand that. Here, elimination, the like terms are already lined up, and all we have to do is multiply equation 1 by 0.25, which is just as efficient. It's just one step, just like subtracting would be. And so here, with elimination, the y's cancel out. I solve for x to get 2. I get y to be 0, so my final answer is 2, 0. Excellent. I hope that was a great review of solving systems. And now we're going to get back into solving some word problems. So directions. Define 2 variables. So that's the first thing they want us to do. Sometimes I like looking for the verbs in the directions to know what actually things they need me to do. Because if I don't answer the question, I can't get credit for it. Define 2 variables and write, there's another verb. So what do they want me to do? Write a system of equations for each word problem below. Solve, there's another verb. They want me to solve the system of equations. Show all my work, so I'll be like step 3.5, and then write your answer in a complete sentence. So there's like 4.5 things they need us to do here. Okay, let's look at number 9. Tickets for a matinee are $5 for children and $8 for adults. The theater sold a total of 142 tickets in one day, and ticket sales totaled $890. How many of each type of ticket did the theater sell? So a few things, we always want to read a word problem twice. Let's read it again. Tickets for the matinee are $5 for children and $8 for adults. The theater sold a total of 142 tickets. Total usually means you add in one day. And ticket sales totaled $890. How many of each type of ticket did the theater sell? Okay, so our restrictions here are the number of tickets sold and the total amount of money. And what are our unknowns? Since it's how many of each type of ticket, I think we're going to have children tickets and adult tickets. I'm going to use A for adult and C for children tickets just to keep the math a little more connected to the context. So number child tickets is going to equal C, and number adult tickets is going to equal A. And we're going to have 2 equations, just like I said. We're going to have an equation for total tickets sold that day and total money in sales. So total tickets sold, well, we had A, adult tickets, and C, child tickets, for a total of 142 tickets. So that means that it's A plus C is equal to 142. Could say C plus A also, no problem there. Total money sold, well, child tickets are $5 each, and we sold C of them. And adult tickets are $8 each, and we sold A of them. So that means we have 8A plus 5C is equal to the total money in sales, $890. Awesome. From here, we could do substitution or elimination. Substitution seems pretty efficient because all we'd have to do is subtract A or C to isolate. If I was doing elimination, I have to multiply by a negative, and I am not fond of that. So I'm going to set up my T table for substitution here. A plus C is 142. 8A plus 5C is 890. I'm going to isolate A, so I'm going to subtract C from both sides, 142 minus C. Take that value and substitute it in for A. So 8 times the quantity of 142 minus C plus 5C is equal to 890. From here, I double check. Yes, I have one equation with one variable. I know how to solve this. Distribute 1,136 is 8 groups of 142. Minus 8C plus 5C is equal to 890. Combine like terms, I'll have 1,136 minus 3C equals 890. Subtract 1,136 from both sides. I get negative 246 is equal to negative 3C. And when I divide both sides by negative 3C, I get C to be 82, which is excellent. Now I just need to solve for A. A is 142 minus 82, so I get A to be 60. Double check to make sure that seems reasonable, and then write your answer in a complete sentence. They sold 82 children tickets and 60 adult tickets. Perfect. I usually like to box or cloud and then underline the important stuff in my answer. Nice. Okay, so why don't you take a look at 10, read it at least twice, underline the important information, define your variables, write your system, solve your system, and write your answer in a complete sentence. Pause the video and we'll go over it as soon as you're ready. Okay, let's see how we did. Number 10, our two unknowns here are number of quarters and number of dimes. The two equations represent the total number of coins because there's 50 coins total. The number of quarters plus the number of dimes is 50. If you used Q and D for quarters and dimes, that's probably better than what I did. So good job there. And the total value of coins, 0.25, the value of a quarter times the number of quarters, plus the value of a dime times the number of dimes is equal to the total money, $8.60. From here, you could have used elimination or substitution. I chose substitution. I isolated X in my total number of coins equation, substituted that in. To have one equation with one unknown to solve for Y to be 26, substitute that back in to solve for X, and wrote my answer in a beautiful sentence. Jasper has 26 dimes and 24 quarters. Also, double check that this makes sense. The one I like checking is the value of the money. Awesome. We have two more word problems to finish up, and then we're done with this lesson. So let's take a look at number 11 together. Taking a look at number 11, it says that two sides of a triangle have the same length. The remaining side is 1/3 as long of each of the other sides. If the perimeter of the triangle is 315 centimeters, what is the length of each side? I need to draw a picture. We're talking about triangles. Okay, two sides of a triangle have the same length. Do you remember what that's called if we have two sides of a triangle that are the same length? Oh, the remaining side is 1/3 as long, so not drawn to scale. Maybe we should do it like this. Okay, that's better. And these little lines mean that those are the same. This is an isosceles triangle. Isosceles triangles have two sides that are the same. Scalene are three sides that are different. Equilateral, all sides are the same. Okay, so from here, since these are the same, I'm going to call them X and X. And we do need two variables because we're going to have two equations, so this must be y. If you were thinking this is 1/3 x, you're not going to have enough information to solve. So from here, the remaining side is 1/3 as long. So we have an equation that y, our third side, is 1/3 of x. And the perimeter is 315. So we can say 2x plus y is equal to 315. And this is great. You could have said x plus x, but this is fine too. From here, well, we already have y isolated. Why don't we use substitution? So I'm going to set up my t-table here. Y is equal to 1/3 x, and 2x plus y is equal to 315. Y is equal to 1/3 x. We're going to substitute that in for y over here. So I'll have 2x plus 1/3 of an x is equal to 315. Remember, 2x is the same thing as 6/3. So here I would have 7/3 of an x is equal to 315. And we know that to undo multiplying by a fraction, we multiply by its multiplicative inverse, also known as the reciprocal. And when we do that, 315 and 7, they cancel out, and we end up getting x to equal 135. From here, we still need to solve for that third side, y over here. Y is equal to 1/3 times 135. And what's great about this is 135 is divisible by 3. Do you know the divisible by 3 trick? 1 plus 3 plus 5 is 9, and 9 is divisible by 3, so the whole number is divisible by 3, which makes y equal to 45. So now let's go back, and since we're talking about lengths, we do need our units. So the 3 sides. And we do want to write out the word 3 since we don't want to mix up using numbers for the measurements and numbers for talking about the amount of sides. We want to write out that word. The 3 sides measure 135 centimeters, 135 centimeters, and 45 centimeters. Double check to make sure that this answer is reasonable, and you can verify mentally by substituting in to see if the equations are true, and they are. Excellent job. Okay, last problem. Taking a look at 12, I'd love for you to finish 12 on your own. Remember to find two variables. We're going to be writing our system of equations, solving your system with whichever method you find most efficient, and then writing your answer in a complete sentence. Go ahead. Okay, you might have noticed something funny. Did something funny happen? I hope you haven't wasted a bunch of time being like, it's just not working, it's just not working. Well, if you said, I said D is the number of dimes and Q is the number of quarters, since we have 100 coins and they're only dimes and quarters. So D plus Q is 100. And for the amount of money to make $11, the value of a dime times the number of dimes plus the value of a quarter times the number of quarters is equal to $11. Well, I decided to use substitution. You could have easily used elimination also. However, when I substituted an 100 minus Q in for D and solved, I got Q to be 6 2/3. This is impossible. You cannot have part of a quarter. Hence, this is no solution. We call this, if you remember, an inconsistent word problem. Inconsistent word problem meaning all of the details of this situation cannot happen at the same time. And we looked at inconsistent word problems back in Module 1, where your equations are all correct, you're doing the math correct, but you end up with an answer that is not logical and cannot happen with all of the restrictions in place. So this is indeed an inconsistent word problem. There is impossible to have 100 coins made up of only dimes and quarters to equal $11. Great job, mini mathematicians. Excellent work. You're doing a fabulous job. Keep it up.